In this video, we are going to solve a few exponential and logarithmic equations. First, we are going to start with log equations. In this, you have sum of two logs on the left-hand side and a single log on the right side, but they all happen to have the same base. So in all of the example problems we are going to see today, the base is going to be the same. There is a separate video where we are going to cover change of base formula and how to solve equations, logarithmic equations where we have logs of different bases. Okay, so here we combine this like so, using the properties of logs. Once you get the left-hand side and right-hand side to be logs, just a single logs, right, of the same base on both sides, then you can just bring the inputs down. You don't have to write the log again, because the only way this statement can be true is if x times x minus 1 is equal to 4x. So bring everything to the left, factor, solve. You get two solutions. It is very important, well, it is not only important, it is a must that you check your answers, okay? Because not all solutions are going to be acceptable. So if x is 0, what happens? Your first expression log x is immediately invalidated, right? Because you cannot have a log 0, and neither can you have a log negative 1 for that matter. So it's done. Whereas x equals 5 is a possible solution because log x will just become log 5, which is okay, and log x minus 1 will become log 4, and that is also okay, right? And log 4x will become log 20, which is also okay. So x equals 5 is the only solution to this equation. Okay, next one. So the first thing I'm going to do is I'm going to combine the two logs on the left, and I'm going to do the same for the right. Then, since I have one single log on the left and one single log on the right with the same base, I can just let them be and write this. Distribute, combine like terms, solve. I check. It looks like they're all going to match. Okay, work out. So this is fine. All right, next one. So I combine the left-hand side into a single log, and since this is a difference, it becomes a quotient. But you can see that the right-hand side is not a log, it is just a number, okay? So I convert this statement into the exponential form, so it becomes 5 to the power of 2 is x plus 1 over x minus 1. 5 to the power of 2 is 25. I can imagine there is a 1 underneath this if you want, so that I can cross multiply. Distribute, combine like terms, solve. And this is my answer. Of course, I have to check. I think it's okay because they're both greater than 1, right? 13 over 12 is greater than 1. So I'm not going to get a negative number or a 0. So this is fine. And that is how you will solve in this situation. one more problem. So when you see a log without a base, please assume base 10. So this is nothing but x minus 4 is 10 to the power of 3. 10 to the power of 3 is 1000. So x is 1004. All right. Okay, let's do one exponential equation. So here, I cannot rewrite 34 as a base 2 exponent. So I convert it into the log form. So this becomes 3x is equal to log 34 to base 2, which means x equals log 34 to base 2 all over 3. And that's my answer. Okay. The first thing I do is get rid of the 2, divide both sides by 2. Then I convert into the logarithmic form, okay, which can be written as ln 17 minus ln 2 if it helps you. So then I divide by 2 on both sides. And this is my answer. So whenever you have a situation while solving an exponential equation where you cannot rewrite as an exponent with the same base, convert it into the logarithmic form. Okay. I'm going to do one more problem. This is where you have two exponents of different bases. So you take log or ln on both sides, because when you do so, you're not actually changing anything, right? Then the power becomes a coefficient. In the left-hand side, we are good, but in the right-hand side, I have to distribute. I get all the terms with x over to one side and leave this number on the right side. I factor the x out, then I divide. And that's my answer. If you don't want a negative in the numerator, you can always flip it like so. And this is going to be my answer. Okay. And that's how you do a problem where you have two exponents of different bases on the left and the right hand side.